Have you ever noticed something strange about the moon? Someone in the Northern Hemisphere will look up and say, "Hey, the moon looks like a smile." Someone in the Southern Hemisphere will look at the exact same moon and say, "Nope, that looks like an upside down smile." The funny thing is, they're both right. Let's explore this. Hello there, welcome back to Star Stuff, where I hope to help out with any confusion you might have about space, science, and Earth things. Today we're going to look at how the moon's orientation changes depending on where you are on Earth, and why this single observation quietly dismantles the flat Earth model. The key observation. Let's start with what we all agree on. People in the Northern Hemisphere, Southern Hemisphere, and the equator all see the same moon on the same night at the same phase, but they do not see it the same way. The moon appears rotated depending on your latitude. That rotation is not random, and it is not explainable on a flat plane. So this is what we see on the globe. Imagine standing on a giant sphere. People in the Northern Hemisphere are effectively looking downward at the moon. People in the Southern Hemisphere are effectively looking upward at it from the opposite side of the globe. So naturally, the moon appears flipped. Not because the moon changes, but because you do. Your orientation in space changes. Let's break it down by hemisphere. In the Northern Hemisphere, the moon's north pole appears at the top. A waxing crescent looks like a right-hand curve. A waning crescent curves to the left. The man in the moon looks upright. This is the version most diagrams show. Now we're going to look at the Southern Hemisphere. Flip your perspective. The moon appears upside down. A waxing crescent curves to the left, and a waning crescent curves to the right. The man in the moon looks inverted. Same moon, same phase, different orientation. This is where things get really uncomfortable for flat Earth. Near the equator, the moon can appear sideways. It can rotate noticeably as it rises and sets. Over a single night, the orientation can visibly change. People close to the equator regularly photograph the moon looking almost horizontal. That only happens if observers are standing on a curved surface. Now we're going to look at all moon phases in both hemispheres. Let's go phase by phase. New moon is invisible everywhere. We don't see the new moon because it's too close to the sun in the sky. The sun is really bright. So there's no orientation difference because there's nothing to see. Flat Earth gets a brief moment of peace here. With a waxing crescent, the Northern Hemisphere, you get the curve on the right. The Southern Hemisphere, the curve is on the left. And the equator often looks like a smile. Already a problem for flat Earth. In the first quarter, the Northern Hemisphere, the right half is illuminated. In the Southern Hemisphere, the left half is illuminated. At the equator, the vertical split can appear tilted or horizontal. Same sun, same moon, different geometry. With a waxing gibbous, illumination grows. The orientation remains hemisphere dependent, and the surface features appear mirrored north versus south. Still one moon, still one explanation. With the full moon, this is the most damaging. The full moon looks upright in the north, upside down in the south, and rotated at the equator. Flat Earth models require everyone to see the moon the same way, and we don't. With the waning phases, everything reverses, but the orientation differences remain the same. No exceptions, no special pleading, no perspective tricks. Now let's look at why Flat Earth can't explain this. Flat Earth claims there's one moon floating above a flat plane, seen from different locations, but on a flat surface, orientation does not flip. Think about it. Rotation would require the moon itself to rotate independently for every observer, or light to bend differently in different directions for different people. That's not perspective. That is magic. Here's the question Flat Earth never answers. Why does the moon appear rotated? Exactly the amount expected for observers standing on a sphere. Not approximately, not sometimes, always. From every latitude, on every continent, for every phase. So this tells us you don't need NASA, you don't need satellites, you don't need equations. You just need two people in opposite hemispheres looking at the same moon. A flat Earth can't survive that conversation. The moon doesn't flip, we do. And the only shape that explains that clearly, consistently, and predictably is a globe. If you enjoyed this breakdown, please like and subscribe to Star Stuff. And if someone tells you the moon looks the same everywhere, ask them which way is up. Cool beans.